Hello everybody and welcome. Let's start solving more problems and questions about momentum and impulse. So let's see this question. We reached question number 4. It says that a 6 kilogram block is sliding to the east across a horizontal frictionless surface with a momentum of 30 kilograms meter per second. It strikes an obstacle. The obstacle exerts an impulse of 10 Newton seconds to the west on the block. So now it's asking me to find the speed of the block after the collision. Okay, so it's a pretty straightforward question. Let's start by trying to illustrate the question. So an object is moving to the east, so it's moving this way, and it has a momentum equal to 30, and it has a mass equal to 6 kilograms. Now, it hits a wall, or an obstacle, or etc. So, if I want to draw it again, when it hits this obstacle, or wall, or etc., this wall is applying an impulse that's equal to 10, and it's saying that it's going to the west. Okay, so we have momentum 30 this way before the collision. Now after it hits the wall, the momentum is going to change some way or another. Okay, so how can we find the velocity of the object after the collision? Well, actually it's pretty straightforward. We know that the impulse is equal to the momentum final minus momentum initial. So it's P final minus P initial. Okay, so I know that the impulse is equal to 10, but it's very important to keep in mind that impulse and momentum, they are vector quantities, so the direction is important. Since the object is going to the left, so I can say that the impulse is actually negative 10. So negative 10 is equal to P final minus P initial. Well, P final, it's the momentum after the collision. That's what I'm looking for. I want to try or I want to find the momentum after the collision. So I'm going to say P final minus P initial. What is P initial? What is the original momentum of the object? Well, it's clear in the question that it's equal to 30. So I can say P initial is equal to 30. Okay? So if I solve the equation, I can say that P final is equal to 20. Okay, so really nice. I got the momentum after the collision, but the question is not asking me to find the momentum. The question is asking me to find the velocity after the collision, but I already know that the momentum is equal to the mass multiplied by velocity, and I already have the momentum, which is equal to 20. This is equal to the mass, which is 6 kilograms. It's given in the question, multiplied by the velocity of the object, which is unknown. So V is simply equal to 20 divided by 6, and the closest answer in this case is equal to 3.3, which is B. Next question. It says that a 1 kilogram laboratory cart is moving with a velocity of 0.5 meters per second due east, and it collides and sticks. Okay, so these keywords are important. It collides and sticks. So what type of collision do we have? We have a totally inelastic collision. Okay, so it hits a similar cart that is initially at rest. Okay, this is also important because this means that the other cart is not moving. After the collisions, the two carts move off together with a velocity of 0.25 meters per second due east. Okay, so it's giving me the velocity after the collision. What is the total momentum, or the total momentum of the frictionless system is 0 before the collision, 0 after the collision, the same before and after the collision, or greater before the collision and then after the collision. Well, okay, it's impossible to be 0 before the collision because we have one of the carts that is moving and it has a velocity, so this is impossible. 0 after the collision, no, it says that they stick together and they are moving due to east, so there's a mass and there's velocity, so this is also impossible. Means that they are the same before and after the collision. Yeah, well, actually we already know that. We know that in any case of any collision, the momentum is always conserved. So if the momentum is conserved, this means that the momentum before is equal to the momentum after. So the answer is C. But let's look at D quickly. It says that the momentum before is greater than the momentum after. That is wrong because we know that momentum is conserved, which means that the momentum before and after the collision is the same. So the great answer is C. Next question. Says here that an object of a mass of 5 kilograms has a momentum of 20 kilograms meters per second. Its speed is most nearly, well, actually it's pretty straightforward. We know that P is equal to M multiplied by V. P is equal to 20. The mass is equal to 5. V is unknown, so we can say that V is equal to 4. So the answer is C. Next question. Cart P, which has a mass of 4 kilograms and a velocity of 6 meters per second, it's going east. collides with another cart called Q, which has the same mass and is at rest. So we have a keyword right here, at rest. If cart Q has a velocity of 6 meters per second east after the collision, the velocity of cart B after the collision will be, well, okay, let's draw it. We have, this is the first cart. This is cart P, okay? It says that it has a mass of 4 kilograms and it has a velocity of 6 meters per second and it's going east, so it's going this way. It collides with another cart, let's call it cart Q. It has a mass of, or it has the same mass, so the mass is 4. It has a velocity equal to 0, so it's not moving. This is before the collision. Now, after the collision, it says that after the collision, Q has a velocity of 6. So the collision happened, okay? And now Q has a velocity of 6 meters per second east. So it's going this way now at a velocity equal to 6. And we already know the mass is 4. It's asking me what is the velocity of object P, which is this object right here. Well, actually, it didn't mention that they stuck together, so we're going to assume that it is an elastic collision. So we're going to say simply that M1 V1 plus M2 V2 is equal to M1 V3 plus M2 V4. Okay, so what is M1 and M2? M1 and M2 are the masses of P and Q, which are 4 and 4. So we have M1 and M2. Let's write it down here. M1, it's equal to M2, and it's equal to 4. Now, what about the velocities? V1, it's the velocity of object P, which is clear that it's equal to 6. So V1 is equal to 6. Now, is it a positive or a negative value? It's a positive value because it's going to the right. We're assuming that the right side is the positive side, okay? Now, what is V2? V2 is the velocity of object Q right here. And since it's at rest, because the question says that it is at rest, this means it's not moving, so V2 is equal to 0. Now, let's go to after the equation here. It says that it's equal to M1 multiplied by V3. Now, V3 is actually the velocity of P after the collision, and it is unknown. The question is asking me to find V3. And finally, V4, it's the velocity of object Q after the collision, which is equal to 6, and it's going to the right, so it's positive 6, because it says in the question that it's going east. So now we have all these inputs, and we have one unknown. Let's solve it quickly. M1 V1 is equal to 4 multiplied by 6 plus 4 multiplied by 0 is equal to 4 multiplied by V3, which we do not know, plus M2 V4, which is equal to 4 multiplied by 6. Well, actually, 4 multiplied by 6 here is 24. 4 multiplied by 0 is 0. This is equal to 4 V3 plus 24. Actually, if we subtract 24 from both sides, we will get that 0 is equal to 4 V3, and this means that V3 is equal to 0. In other words, this object, after the collision, it's going to push object Q this way, and it will stop totally in its place. Well, some of these questions, actually with some practice, you will understand that you didn't even have to solve the question in the first place, because they had the same masses, they collided with each other, and Q, it's just like it took the velocity of 6 and it started moving with this velocity. And since momentum is conserved, since all the velocity was taken by object Q, it left object P with 0 velocity. So you don't even have to solve it. You can just say that the answer is 0. But in any case, if you didn't think of this solution, if you didn't think that the answer is 0 directly, you can just solve it using the equation and you will get that the answer is 0. Okay? So we're trying to build some common sense in these types of questions. Another question, it's asking me here, which of the following statements is true of a system of two particles that collide elastically? It says that the collision is an elastic collision, okay? The momentum and the energy of the system are the same before and after the collision. The momentum of the system is the same before and after the collision, but the energy is not. The particles stick together. The particles are permanently deformed. Well, since it's an elastic collision, we can just exclude C and D because they do not stick together when it's an elastic collision. Now, let's think about A and B. Let's go to B. B says that the momentum of the system is conserved but the energy is not conserved. Well, that is correct if the system is not an elastic system. If it was an inelastic system or a totally inelastic system, because in elastic systems, the momentum and energy are conserved, so the true answer is A. Now, next question. If an object with constant mass is to have the magnitude of its momentum increased, the object must have a high velocity, lose potential energy, change the direction of the velocity, be accelerated. So again, let's analyze the question. If an object with constant mass is to have the magnitude of momentum increased, okay, so let's just simplify things. We know that momentum is equal to mass multiplied by velocity, okay? Since it says that we increased the momentum and the mass is constant, it did not change. The object must have high velocity, lose potential energy, change the direction of the velocity, be accelerated. Well, okay. To increase the magnitude of the momentum while the mass is the same, the only thing that we must have done is that we increase the velocity, okay? So some of you may say, okay, so the answer is have a high velocity. No. If an object had a high velocity and a constant high velocity, the momentum would not change. The only way you can change in the momentum with keeping the mass constant is by increasing the velocity. So what we did is that we increased velocity, okay? To increase momentum, we will increase velocity, okay? So let's think about the choices again. Have a high velocity is not a correct answer because it does not mean that the velocity increased. Well, lose potential energy means that the object gained kinetic energy, but that does not by sure, or we're not sure 100% that the velocity is increasing. Change the direction of the velocity. It does not by fact mean that the velocity was increased. And finally, be accelerated. Well, actually, the word acceleration, we introduced the word acceleration before, is changing the velocity, either increasing or decreasing. So if the object is now accelerating, this means that the velocity is increasing, and the velocity is increasing, this means that the momentum is increasing. So the best answer actually here is be accelerated, okay? Next question. A 2,000 kilogram dump truck is initially coasting on a level surface at a constant speed of 25 meters per second. As the truck coasts under a loading ramp, a 500 kilogram load is dropped onto the truck. The speed of the truck and the load immediately afterwards is, well, actually, let's try to illustrate this figure. So we have a truck. Mind my drawing, please. Okay, it's moving at a speed equal to 25 meters per second, and it has a mass equal to 2,000. Okay, so then, and a load was dumped into this truck. Okay, so this is the load, and now the mass is going to be equal to 2,000 and additional 500. So the mass now is equal to 2,500. Okay, it's asking me what is the speed of the truck after the load is added. So we're going to say that what's going to help us solve this problem is momentum. We know that the momentum before is equal to the momentum after. Okay, so the momentum before is equal to 2,000 multiplied by 25. Okay, the momentum after is equal to 2,000, sorry, there's a zero here, 2,500 multiplied by the velocity that we do not know. So we can say that these values are equal to each other. So we can say that 2,000 multiplied by 25 is equal to 2,500 multiplied by the velocity, and the answer in this case is equal to 50,000. It's equal to 2,500 multiplied by the velocity. So the velocity is equal to 20 meters per second. Let's see our choices. So the choice or the answer in this case is C. Okay, so we solved now a bunch of questions on momentum and impulse. Stay tuned. In the next videos we will be introducing more topics. See you then.